Hello everyone, here's a demo for our Big Data Analytics final project. This is the website we built for our travel planning system. Basically, in our travel planning system, we want to achieve three goals. First, we want to save money and time on travel. Second, we want to provide recommendations for our users and optimal travel plan. Third, we can predict traveling costs based on our machine learning models. In our project, we used NYC taxi trip data which has been available online. And we have also removed around 4.1 million dirty records on HDFS, such as null data, invalid geolocations. We also use geohash to discretize the geodata. That helps us to encode the GPS points. In the system, we also used two machine learning algorithms. The first one is random forest regression, and the second one is linear regression. So, in this website, we have built three main functions to our users. The first one is HotMap, which is used to visualize the predicted data from our trained machine learning models. The second one is recommendation. In this part, we have provided some input boxes which allow users to enter their starting point and destination and their time, so they can get some recommendations for their upcoming trips. The third part is cost prediction function, which provided users to get an estimated cost based on their planned geolocations and predicted time. So in the next few minutes, we're gonna go over the details of each function, and we're gonna also do some explanation of our algorithms.
After getting the predicted results of the temporal spatial distribution of the number of taxi trips in New York City, we visualize the results on a map using CattleDB. The flashing area stands for the number of taxi trips happened at a specific time and location. The lighter the area is, the more taxi trips there are in the region, and the more concentrated the points, the busier those blocks are. Below is a heat map of New York City, generated using the predicted taxi trips data. The hottest areas, which correspond to the reddest region, as you can see, are Times Square and Penn Station in Manhattan. And the second and third hottest areas are LaGuardia Airport and JFK Airport. Here's a comparison of actual daily average taxi trip volumes on the left side with the predicted daily taxi volumes on the right side. One can feel from the visualization that the prediction is very good, but our evaluation, the average prediction accuracy is about 79%.
In the recommendation part, we provide three text input boxes for our user to enter their starting point, destination, and the time duration. The time duration here is used to generate a predicted night chart for pickup density based on the machine learning model. For example here, as we enter the starting point, Grand Central, and the destination JFK Airport, and we also have a time duration 8 hours, our system is able to generate a chart. This chart shows an 8-hour duration pickup density prediction. So this is from our current time 2 p.m. to 10 p.m. As the chart shows here, the predicted rush hours is around 6 p.m. So for users who wants to go LaGuardia from Grand Central, we suggest them to avoid this time so that they can have a lower cost and less time on travel. For the cost prediction function, we allow users to enter their starting point and destination so that we can input it to our linear regression model and get an estimated cost. For example here, as I entered, I'm traveling from Grand Central to JFK Airport, and after user submitted, the system will calculate the estimated cost based on their current location and the predicted time duration.
Okay, for this part, I will just briefly explain the process of training our model to predict the real-time traffic pickup density. Okay, so for this model, we use the Python scalar, and the API I use is briefly the key neighbor regressor. So the data I use is the training set. So the training set is a process of the data cleaning and the data processing. I just drop some unnecessary attributes to accelerate the training process, and I also make some expand of the training set because I want to the time is vary from 0 o'clock to 24, and the interval is 30 minutes. So in the end, the training set was expanded to 64 columns. This is our training model here. I call this API, and this is our training. This is our training model parameters, and this is our training model. Okay, for this part, I will briefly explain how the backend works. As we can see here, the machine learning model was loaded to predict the pickup density, and the input is the time and the geolocation. I use the socket.io to connect the front end and the back end. So this is our model to predict the cost. So this model was well trained, and the accuracy is above 98%. So to get the prediction, when the backend receive the command from the front end, it will firstly construct the 64 parameters from the transform data and predict density, and then it will repeatedly call it based on the duration the user want to see. And that's it from the backend.
For predicting the traveling cost, we use a simple linear regression model. We include two most critical features, namely distance and traveling duration, as predictors, and use ordinary least square method to train the linear model. The prediction accuracy evaluated using a held-out testing set is 98%.